Yeah, there you go. I opened it. Thanks everybody for sticking it out. I'll try and see if I can be in any way entertaining so that you don't fall asleep here. Mike asked me to come and tell about all the stuff we do at Airbus, so I was very happy to fly in yesterday and also to listen to the many really, really good presentations today. And I'll be here tomorrow as well. It's a really exciting program. Airbus has actually been doing this for quite a while, and a while longer than when I joined in November of 2016. And 2018 is going to be a really exciting year because it's going to be the year where a lot of the projects that have taken 2 to 3 years from starting to first demonstrations is going to happen. So we'll have 3 major milestones this year. So very exciting 2018 for urban air mobility at Airbus. So for those of you who might think Airbus is a very large company, we got a lot of different innovation activities. Oh.
Separate those.
Separate them, yeah. Okay. One in each pocket.
Thank you.
Here. Yeah, so this little wheel of fortune shows the innovation ecosystem at Airbus. And the reason I show it is because you might have met some of my colleagues from our innovation center here in California, in San Jose, and they're part of the same ecosystem which I'm part of. The idea is to set a strategy and see the future. You guys are all part of that, electrical, autonomous, connected machines building new materials in new digital ways. So those overall strategies drive our technology roadmaps. The technology roadmaps drive our research projects and demonstrations, flying demonstrations. For something more disruptive, we come here in Silicon Valley or in our new innovation center in Shenzhen, where we do sort of rapid innovation. For more external and opportunistic activities, we have an incubator called BizLabs with activities all over the world. And we got our Airbus Ventures, which is investing in promising startups related to urban air mobility. So we're really trying to pull all the levers to make this innovation happen. And I sit there in the middle and try to push things in the right direction. I wanted to pick up perhaps what Mike said, an interesting background. I've joined from Uber, and Uber is, as we know, with Mark and all the rest of the team, such a big player now in urban air mobility. I think it's because not only is it a fascinating topic, to be able to fly and get people faster from A to B, but it's also a new potential transportation network. And what's really exciting about transportation network from a more business perspective is that they have these remarkable network effects. And network effects are very valuable because they mean that when more and more people use a service, the value expands faster than the value that's coming in. And that's, in the example of ride sharing, more drivers come in, that means more people can use a service, that means you can get a service faster, that means more demand, and this virtuous cycle is actually something we can observe in almost every transport network of the world, whether it's at sea, on the ground, and the idea is probably that it will also happen in the air. And there's a gentleman called Metcalf who looked at telecommunications network, and he could see that you had the same effects there, and the value of the network is sort of the square of the value of the participant. So it's an exponentially valuable mechanism. This also means that the value of the network or the creation of the network is much higher than the individual contribution. And just because I spent 15 years in transportation, I've seen that in many places, not just in ride sharing, where Lyft and Uber and Didi and Grab and Ola and all these companies all over the world have gone into that virtuous cycle and created these fascinating business models that have raised over, I think, $150 billion of capital, or at least their value to be. We also seen it in on-demand food delivery, where the same very powerful network effects means that the business that can get everyone a meal fast in our big cities can be very, very lucrative. I think the third and most notable example is probably the new bike sharing phenomenon that's been kicked off in China, where within just a year, Mobike and Ofo have created the world's largest transit system, moving tens of millions of people around on a bike and shifting a lot of people out of the cars. These transport network effects are so powerful, which allows you to raise a lot of capital, which again allows you to put out new transport services at speeds that are completely unheard of. Creating the world's largest transport system in just a year using mobile technology and bicycles is quite impressive. I've also seen it in container shipping, which is this idea of global trade on ships in modularized containers. And here you have the same effects, although unlike on the bikes and on the couriers and on the cars that we saw, here the industry changed a bit. It wasn't so much the digital platform and all the contributors, it was big, fully integrated transport systems. So the companies would build and develop the infrastructure, they would build and develop the port agents and the sales force, and in addition to the ships themselves, which this one I think shows how big they ended up getting because of those very powerful effects. Another example from here, the United Parcel Service. Actually, when Ford Model T created the car, they very quickly created a business out of getting people their goods and services delivered. And today, UPS is the biggest transportation company in the world, $90 billion valuation, just a bit higher than Ubers and the Didis, and it took 100 years maybe to make it. But they also, as we know, have their own cars and in a fully integrated way. No one gets between them and the customer. What's the relevance for urban air mobility is asking, will we see the same kind of powerful network effects, or will this more be of a point-to-point like service, like back and forth from the airport or major hubs? And I think from the studies we've done, and we work with leading universities in the US and in Europe, and when we continue to investigate the topic, it does seem like there are the possibilities of creating very dense urban air mobility networks, which will have this virtuous cycle and potentially allow the kind of utilization levels which make it so cheap and affordable. It will, however, happen a bit over time, so it won't start like that, but it will certainly end like that. And why am I spending so much time talking about networks and that? It's because it means something for the whole ecosystem. It means something for a manufacturer of vehicles who wants to be part of this very exciting future. And we at Airbus have looked at this and said, okay, if these networks effects are there, we're going to take the UPS model and build a fully integrated transportation service, much more than the airframes that we do today. And the vision for that, we made a little movie about, which I'd like to show you. It's coming on the next slide. Sorry, this one, just before the video, is a slide that shows the first, let's say, footprint of a network. This is from a couple of months of flights last year in Sao Paulo, where we see up in the upper left corner, it's the airport, and down you have the different nodes that are starting to come And you can see that a lot of the volume moves back and forth from the airport, but there's about 10 or 15 or so nodes that have appeared in the downtown Sao Paulo area, and also connections between the nodes. And the network effects haven't yet kicked in yet. They're not really there, and that means a lot of deadhead, so a lot of empty flights. But as this network scales and we'll have more and more dots, the network effects will come and we can get at this 60-70% utilization, which for a 4-passenger vehicle means we can be as cheap as a taxi cab. Interesting point is how fast we can get there and how we can overcome the constraints to them. Yeah, so here's the video. It's the vision for multimodal integrated mobility as a service. It's a concept we envisaged together with a very large automotive group, the Volkswagen Group, I think until recently the biggest one, and they're very cool design people, Ital Design, who otherwise normally builds very cool looking cars. Yeah, so I think in addition to being sort of everywhere from booking the ride and getting both the ground piece and the air piece to work together, I think what we also learned from the feedback we got to this concept, the feedback was quite overwhelming. In just a few weeks, more than 1 million people watched this thing on YouTube. The opportunity, and just leveraging a bit the previous presentation, for also modularizing the cabin to perhaps be able to carry cargoes or be fitted tailored for a public service mission or an ambulance, means that modularity is still something we're quite interested in, also from a technical perspective. The other thing I want to say is that what's been really interesting working with the automotive world is their emphasis on interior, the cabin, the customer experience, and the kind of processes they put into developing that. And the privilege of automotive is also you can put something on a show way before the aerospace sector would normally do that, way before you actually have flown it. But you do that to engage with the public and see how they respond to it, and in a much more iterative way find the right configuration. And so with my story of the transport network and what that means for us as a company, meaning that we need to reposition as a mobility company, potentially working with automotives, I wanted to also tell what we're actually building and flying. The first thing we started doing was was to say, well, if we're gonna build a system of systems, so airspace integration, infrastructure, interaction with end customers, let's take a couple of drones and build a full system. And we did that down in Singapore, and we will here, sooner rather than later, and hopefully at the Singapore Air Show, demonstrate a package delivery service with an integrated airspace system to take that as the sort of minimal viable system to start working the problem end to end. The next thing, and you've seen it throughout the day, is the Vahana, which is a single, potentially two-seated autonomous tilt-wing vehicle that's right now going through flight test not so far from here. A very promising design that with the tilting wing achieves the potentially highest level of flight efficiency and so a very good range on the available battery capacity. We believe with this design we can definitely meet the timelines that's been discussed through the day in terms of having a commercially viable design. We've also embarked on a radically different design, which is optimizing for simplicity and certifiability. So it's optionally piloted. It's also a full 4-seat vehicle, which is certainly attractive. And it's a multi-rotor, and we hope that we'll fly the vehicle in full scale before the end of the year. Now, the data I showed you from Sao Paulo at the beginning of the presentation comes from Voom. Voom is a on-demand helicopter service in Sao Paulo that's been going on for a while, and it is now a fully running business. I think Uma will be here tomorrow to tell you a bit more about it at one of the good working groups. So I think the last project really puts a circle around it, and this is the project Altiscope, which is our first step into seeing what needs to happen to increase the density of flight at the levels that could be demanded by the market. And so we've launched Project Altiscope also here in the Innovation Center to start simulating different combinations of drones and aerial mobility vehicles and use that to have a very constructive dialogue with regulators around the world on what the policies they need to make need to look like. They're also working on standards for radios, for communications, and I think the interest from at least the European authorities and also here in working with us on defining and making it more real. What is it actually? Is it 100,000 vehicle? Is it 1,000 vehicle? What is it going to look like? And what does it mean for the systems and processes to be made? So we're trying to cover all the problems and make sure that there will be a future where there's infrastructure, there is airspace systems and the right vehicles so that the vision can become a reality. In addition to those own projects, so Skyways and Altiscope and Vahana, City Airbus and Voom, we're also partnering externally where we need to. We have a big thing with Siemens on developing electrical motors. We work with Unifly and Air Maps, the sort of drone-focused airspace systems developers. And we place venture investments across the spectrum. So we're trying to get all the problems solved in our own way to cover this new and exciting value chain that needs to be built. The last thing perhaps is that what we did when counting all the different concepts, and I think maybe there's a lot of statistics on the designs, but those three major the configurations, the sort of rotary wing or multicopter, the tilt something, and the hybrid. We worked with all of them, and we have, as a City Airbus and Vahana, but we also have worked with something called a quad cruiser, which is this hybrid configuration that you've seen. And that means we think we'll have the right technology eventually once the sort of design space has fully converged. And then on the approach to autonomy, I think no one really knows whether we can just take one big step to fully autonomous, or whether it'll be more of an incremental. And here's a slide from the automotives, and they are doing exactly those two things. The startups and some of the tech companies like Google, they try to leapfrog and work all the way through all the problems and then come to the market. Level 1, level 2, level 3, level 4, 5 of autonomy. And then there are the sort of typical automotives that are like increasingly adding levels of autonomy to their more like driver assistance based technologies. With the City Airbus, we do the upper one, and with the Vahana, you could say we're doing the bottom one. And no one really knows which one of them will get up at the upper left corner first. But with both of them, we hope to have what it takes. And then we were happy to partner with the EASA to build a certification framework for more autonomous systems. This doesn't only cover urban air mobility, but also other vehicle types. And there's a lot of interest actually in Europe right now to be part of this thing, which I think, to be honest, has been started here in the US. I don't know if I have time. Am I over time? Okay, well, the last thing is just to say that there is a relevant overlap between vertical flight of people and packages, like I think this community is mostly coming from, and then the sort of emerging commercial drone sector. Commercial drones are used to, do imagery. They're, they want to be used for flying around packages, and the main overlap, of course, is the airspace technology, which will make it possible for any kind of UAV to live in harmony with UAM vehicles. And what we did first on creating a business in commercial drones was to launch a Airbus Aerial earlier last year, which is a remote sensing business that's launched in the US, so they can fly out and take pictures and combine that with satellite imagery. So by having both in our commercial drone business in Airbus and our projects for urban air mobility, we think we can bring urban air mobility into the many drone-related topics and discussions on U-Space and UTM. And here's a collaboration we did with CESAR-JU, the funding body for public-private partnerships for the development of ATM and UTM technology in Europe. And here's what came out of that just at the end of last year in a conference in Helsinki. The Director General for Transport presented this one.
The birth of aviation and the advances made since have fundamentally changed our world. Today, people around the globe are enjoying greater mobility and connectivity than ever before. By 2030, new types of traffic will share our airspace, and our skies are projected to be 10 times busier. In this new era of aviation, these novel vehicles will perform a range of work enabled by U-Space services. Farmers will be better able to maintain crop quality and yields, increasing food security for our citizens. Energy companies will be able to monitor gas lines and solar panels, ensuring a constant supply of power for our industries and homes. Incorporating new aircraft types and services will improve the flow of people and goods, boosting economic opportunities. Electric-powered air taxis will ferry people to their final destinations. Autonomous cargo aircraft will connect local manufacturing centers with global markets. Manned and unmanned traffic will operate in harmony, serving people and delivering a myriad of services. Packages will be delivered quickly and efficiently without adding congestion to our roads. As the number of flights increase, U-Space services will provide coordination and oversight to make safe operations a reality. Our airspace will be dynamically managed, improving through shared operational data. For example, during a sports event, most flights will be rerouted around the stadium. Only authorized media and emergency vehicles may access the airspace. Citizens will have new ways of moving, working, and living. A digital European sky holds great promise for our citizens and our businesses as we travel into the next age of aviation.
That's all I had. Thank you very much for listening.